So in my previous lecture, we talked about task analysis and some of the characteristics of GOMS model, which is Human Information Processor model. So in this part of the lecture, we'll discuss about cognitive task analysis. So let's discuss in detail. So we have already gone through these slides. So let me go directly to the cognitive task analysis. So cognitive task analysis is not really a single method, but it's more of a type of method for approaching the evaluation of how people complete tasks. So performing a cognitive task analysis involves a number of different techniques and methods that we'll discuss more when we discuss the design lifecycle. For now though, we are interested in what kinds of information we are trying to gather, not how we are gathering it. So, cognitive task analyses are especially concerned with understanding the underlying thought process when performing a task. Not just what we can see, but specifically what we can't see. There are a lot of different methods for performing cognitive task analysis, but most methods follow a particular common sequence. First, we want to collect some preliminary knowledge. While we as interface designers don't need to become experts in a field, we need a good bit of familiarity with it. So we might observe people performing the task. For example, in navigation, we might just watch someone driving and using a GPS. Our second step is to identify knowledge representations. In other words, what kinds of things does a user need to know to complete their task? Note that we are not yet concerned with the actual knowledge they have, only the types or structures of the knowledge that they have. For instance, we want to know, does this task involves a series of steps to do in a certain order? Does it involve a collection of tasks to check off in any order? Does it involve a web of knowledge to memorize? For navigation, for example, we would identify that the structure of the knowledge is a sequence of actions and order as well as knowledge of things to monitor as we go. Now, the third stage, we actually want to populate those knowledge representations. This is the stage where we start to recognize what the user actually knows. With navigation, for example, they know to start the GPS, to enter an address, and to obey the turns while monitoring traffic and speed and things like that. During this stage, we identify all the specific actions they take, the knowledge they must have in mind to take those actions, the interruptions that can change their thought processes, the equipment involved, and the sensory experience of the users. We do this by applying focused knowledge elicitation methods. In other words, we get user to tell us what's going on in their heads or what's going on in their environment. Or sometimes we do things that help us understand parts of the task that the user isn't themselves aware of. Then we analyze and verify the data we acquired. Part of that is just confirming with the people we observe that our understanding is correct. We might watch them do something and infer it for one reason when in reality it's for a very different reason. So we want to present to our users results and make sure that they agree with our understanding of their task. Then we attempt to formalize it into structures that can be compared and summarized across multiple data gathering methods. Finally, we format our results for the intended application. We need to take those results and format them in a way that's useful for interface design. We want to develop models that show what the user was thinking, feeling, and remembering at any given time, and make those relationships really explicit. The result might look something like this. So here we see a very high level model of the process of driving to destination. What's interesting to note is that these tasks in the middle, like let me on my pointer. So these tasks in the middle are highly cognitive rather than observable. If I had no knowledge about driving and I sat in the passenger seat watching the driver, I might never know that they are monitoring their how they are monitoring their route progress or keeping an eye on their dashboard for how much fuel they have left. If you have kids or young siblings, you may have experienced this personally actually. Two kids sitting in the back seat, mommy or daddy are just sitting in the driver's seat, just like they are sitting in the passenger seat. So they don't have a full understanding of the fact that you have a much higher cognitive load and you are doing a lot more things than while you are driving than they are. That's because that you are doing is not observable. That's because that what you are doing is not observable. It's all in your head. So to get at these things, I might have the user to think out loud about what they are doing while they are doing it. I might have them tell me what they are thinking while they are driving the car. That would give me some insights into these cognitive elements of the task. Now, another characteristics of the cognitive task analysis is hierarchical task analysis, and we'll discuss that in a while. That why we call them hierarchical. Cognitive task analysis advocates building models of human reasoning and decision making in complex tasks. So, however, a challenge presented here is that very often large tasks are actually composed of many multiple smaller tasks. We can see this plainly present in our cognitive model of driving. These tasks are so high level that it's almost useful to describe driving in these terms. Each part can be broken down into various subtasks, like iteratively checking all the cars around you, or periodically checking how long it is until next turn needs to be made. What's more, these smaller tasks could then be used in different contexts. For instance, route monitoring, which is here, isn't only useful when driving a car. It might be useful while running or biking or while riding as a passenger. Now, traffic monitoring here might be something that autonomous vehicles might do, not just the human user. So the analysis of a task in a particular context could be useful in designing interfaces for other contexts if we break the analysis down into subtasks. So let's take an example of this. Here is a somewhat simple model of the act of buying something online. Notice that a lot of the tasks involved here are general to anyone shopping on any website, and yet every website needs to provide all of these functions. As a side note, notice all the interesting analogy going on with the top two, like this: fill cart and proceed to checkout. Online, there is no cart or checkout station, but we borrowed those to help the user understand the shopping process online and how similar it is to shopping in a store. Now, anyway, if we treat this cognitive task analysis more hierarchically, like breaking down into subtasks, we can start to see a well-defined subtask around this checkout process. Every online vendor I have ever encountered has these steps in this checkout process. Now, because this is so well defined, we can actually leverage existing tools, like existing payment widgets or something like PayPal. This hierarchical task analysis helps us understand what tools might already be available to accomplish certain portions of our task, or how we might design certain things to transfer between different tasks and different contexts. Hierarchical task analysis also lets the designers of the site abstract over this part of the process and focus more on what might make their particular site unique. This kind of task analysis is so common that you generally will find tasks and subtasks whenever you are looking at the results of a cognitive task analysis. So it's important to remember the strengths supplied by this hierarchy, abstracting out unnecessary details for a certain level of abstraction, modularizing designs or principles so they can be transferred between different tasks or different contexts. and organizing the cognitive task analysis in a way that makes it easier to understand and reason over. Last, it's really important to note that cognitive and hierarchical task analysis that we have shown here are extremely simplistic, mostly, honestly, because of the limited screen real estate. When you are creating a real cognitive model, you will likely have several levels of abstraction, several different states, and additional annotating information like what the user has to keep in mind or how they might be feeling at a certain stage in the analysis. I will show you some examples of some good thorough models in the next slide. Now, one of the examples is accessing a baby in neonatal incubator. Now you can see here that how the tasks are actually broken in different subtasks and how they are hierarchically represented here, and how things are annotated so that the users don't have to keep everything in mind, but still they have to keep some things so that we can say that their cognitive load will be much higher in this case than the one which is not performing the task at all. So this is one of the examples which can the details much further can be found in this paper, which is the design of neonatal incubators, a systems oriented human centered approach, and it's available on the ResearchGate if you want to like to read it. Now another example here is like how to allow the patient to survive the surgery. Now of course you can either go this way, which is to adjust to the time characteristics of the situation, to carry out general anesthesia, to maintain safety, to maintain quality, and then of course all the things are hierarchically expanded and some annotations are provided uh, for this cognitive task analysis. And for the details, you can refer to this website. Another example of graphical representation to clean the house is this. Now here, look at the annotations that how they provided and how the subtasks are actually divided in how the task is actually divided into different subtasks. For more details, you can of course refer to this website. Now let's see a design challenge for a security system. We have already visited it and we have discussed it in the context of Combs model. But let's watch the video of a user disabling his or her security system again. This time though, let's try to approach this from a more cognitive task analysis perspective. We won't be able to do that fully because doing a full cognitive task analysis means interviewing, asking the user to think out loud and more, but we can at least try out this approach. So remember, in doing a cognitive task analysis for a task like this, your goal is to build a model of the sequence of thoughts that's going on inside the user's head. Pay special attention to what the user needs to remember at each step of the process. Take a moment to reflect and let me know on the Google Classroom or in the comment section. So you have seen the example. So let's discuss it. Let's discuss it in Google Classroom, or you can comment in the section that how we can design a cognitive task analysis for this kind of example. But what we saw here was to get inside and disable the alarm. There was a sequence of actions that had to be completed, but some of them can be completed in a different orders. If the user uses keypad, the user had to unlock the door and then open the door. Then the user had to disable the alarm using keypad or close the door, and after closing the door, the user could relock the door, though the user could also do that before disabling the alarm. So there is some choice there. With the keychain, the sequence of the tasks related to the door remain the same, but the user has the option of disabling the alarm before even entering. However, that require remembering to do so. When using the keypad, the user doesn't have to remember because the alarm beeps at the user until the user turns it off, but the user has to remember key code. Performing these cognitive task analysis gives us the information necessary to evaluate different approaches and look for the areas of improvement. For example, if the user can disable the alarm just by pressing the keychain button, why does the user need to press it at all? Why just it didn't detect that the user is coming in with the keychain in her pocket? And there are some systems that can actually do that. They can there is a RFID technology. So if you have a key card and your system or the keypad has a built-in RFID detector, then it can just detect the RFID card in your pocket, and it just uses that kind of stuff to understand that the user is authorized to enter the door. So just like Gomes' model, cognitive task analysis also has some strengths and weaknesses. Now, one strength is that they emphasize mental processes, unlike the Gomes model. Cognitive task analysis puts an emphasis on what's going on inside the user's head. It's thus much better equipped to understand how experts think and work. The information it generates is also formal enough to be used for interface design, for comparison, and more alternatives. There are disadvantages though. The cognitive task analyses are incredibly time intensive to perform. They involve talking to multiple experts for extended period of time and systematically analyze the data. A second weakness is that the cognitive task analysis risks de-emphasizing context. In zooming in into the individual's thought processes, cognitive task analysis risks the de-emphasizing details that are out in the real world, like the role of physical capabilities or interactions among different people or different artifacts. In third, like Gomes, model's cognitive task analysis also isn't well suited for the novices. It's well suited to expert users who have very strong models of the way they work and clearly understand the mental thought processes. But they are not very well suited for novice users who still try to learn how to use an interface. Now, Gomes and cognitive task analysis are just two of the many alternatives to understanding how users approach tasks. More in line with the human information processor models like Gomes models, there exist models like KLM, TLM, and MHP, which capture even finer grain actions for estimating performance speed. There are other extensions to Gomes as well that add things like subgoals or other ways of expressing content like CPM Gomes and N-Gomes L. CPM Gomes focuses on parallel tasks, while N-Gomes L provides a natural language interface for interacting with Gomes model. Now, more on the lines of the cognitive models, there exist other methods as well, like CDM, critical decision method, task knowledge structures, TKS, cognitive function model, CFM, applied cognitive task analysis, CTA, ACTA as you can call it, and skill-based cognitive task analysis. CDM puts a focus on places where critical decisions occur. TKS focuses on the nature of humans' knowledge. CFM focuses on complexity. ACTA and skill-based CTA are two ways of gathering the information necessary to create a cognitive model. There also exist other frameworks more common in other disciplines. For example, production systems are common to an artificial intelligence, but they are intended to model cognitive systems the same way these cognitive models do. So we can apply production systems here as well and attempt to prescribe rules for users to follow. Now, every possible application of HCI involves user completing some sort of task, and that task might be something within a domain. In educational technology, for example, that task might be learning how to do a certain kind of problem. If your area is more technological, the task might be something that the user is doing through your application, like using virtual reality and gesture recognition to sculpt the virtual statue. Take a moment and try to think of the kind of tasks you might be interested in exploring in your chosen application area. Did they lend themselves more to an information processor model like Holmes, or to cognitive models like hierarchical task analysis? And how can you tell? Consider your mini project and submit your assignment by next week by considering the information you got through this lecture. Now, in this lecture, we have talked at length about two general methods for approaching task analysis. One, the Gomes family of approaches tries to distill tasks down to their goals, operators, methods, and selection rules. The other is cognitive task analysis, aimed to get into the head of the user and understand what they are thinking, feeling, and remembering at every stage of the task. When we discussed design life cycles in our lectures, we focused a bit on how to fill these miles with information. But our focus there is on the methods for gathering the information rather than the structure of the information itself. So it's important to keep these methods in mind when we talk about it. So this task analysis lecture has been completed, and if you have any questions, just put down your questions on the Google Classroom or save it for our live session, which is on Monday. So you can ask me questions related to the slides, but just note the slide number and let me know that which slide number it's like with which slide you are facing problems to understand. So let me know in the live session as well as on Google Classroom, and hope that you will follow the next lectures which I'll upload very soon. Thank you.